Hello, Professor. This is Vandana, and I have done project on the dataset of crisis data, which is collected from the city of Seattle from the Department of Police. So this data is all about, say, suppose if a person has a some crisis, any kind of crisis happen in a particular area, particular location, in a particular apartment or a particular house, and when the person calls out on an emergency number for the police, and and when a particular human being or a person complaints regarding the crisis, what they're going through. Then the police department records in very detail about what the passenger is showing. Like it has a unique template ID which counts the crisis. And whenever a person is facing difficulty in terms of calamities or basic essential security, or if if there's any theft happened or any kind of damage has happened from unknowing person, so then the people process Seattle Police Department and they record everything in a record, such as call type from which number the passenger has called, say like 911, and initial call type, what initial complaint they have given. And also, if a passenger requests a crisis intervention team, so crisis intervention team is a kind of a say it might be a she shuttle team which is particularly for women or a police officers. And if a passenger requests a CIT team, that is crisis intervention team, then the record tells it whether the CIT officer, what gender is a CIT officer, what race, what is the CIT officer's ID, and the place of birth of the CIT officer, the years of experience he has in the he or she has in the particular police department, and whether the CIT officer is requested or not, whether the CIT officer is dispatched or arrived to the particular location or not, um, and so as. And the main object to which I wanted to do for this project is to analyze the factors affecting and influencing the crisis contacts made by the police department. So this can be used in improving and handling the crisis management effectively. So here I'm going to predict CIT certified indicator. So CIT is nothing but crisis intervention team. So the CIT certified indicator is the nothing but the place where when the passenger has called to the emergency services, say for the police department, and when the particular person or human being has requested for the CIT team. So whether the CIT team is there at the particular event or not after the request of the human being. So if the police has arrived or the CIT team has arrived to the particular team, then the CIT indicator 1 is going to be as yes, they have arrived. And if not, that's no, the CIT certified indicator is no, if the CIT team is not available. So the data is provided by City of Seattle. This is the source string which I specified, and the target feature which I have explained recently, the CIT certified indicator. The number of rows it had is 71.6K and the column is 25. So these are the implementation steps. So let's go into one by one step in detail. The first, collecting and defining it. So here the data set is read in the form of displaying data frame. The columns are listed. The information is printed about the data, and the unique values are displayed, and all the necessary libraries which are required for the data frame and to perform the analysis and the regression, the classifiers. So each and every library which is uh, which we wanted to use and what are the libraries we want. So we are defining. So that's our collecting and defining data. So perceiving the stats on the data is nothing but summarizing numerical columns, how many, and displaying the description of all columns, like in detail what the CIT certified indicator say if suppose is 0 or 1, the template ID, CIT officer requested, CIT officer dispatched, CIT officer arrived, the race, years of experience, gender, place of birth. So There are in total there are 25 columns. So each and every column is explained in detail. And also they are displaying some quite some amount of reported data with respect to the months and years of display. And then converting CIT indicator from categorical to numerical. So as I've explained before, CIT indicator. So CIT indicator is going to be 0 if the CIT team is not there, and CIT indicator is going to be 1 if the CIT officer is there. So accordingly, they have given in terms of why no. So we are converting it from categorical to numerical. And then we have done the exploratory data analysis. So graphs are plotted against between CIT certified indicator and respected its corresponding features related to CIT, such as graph plotting between a CIT indicator with respect to the month, with respect to the occurred month, and so on. And then feature engineering and feature selection. So here it's kind of the data cleaning is done here. So throughout the data frame, so we are identifying null values by the function of these null, and we are looking for how how many rows or how many columns has the null values, and we are omitting and avoiding and replacing these null values with the normal values, and we are converting some important data columns from category to numerical. And as I have mentioned earlier, we are imputing missing values and rechecking whether the missing values is done here. So still, if there are any missing values, so we are again and again we are imputing, and once we are once we are checked properly, once the missing values are not there in the data frame, then we are going to we are going to collect some important features, and we are going to perform the CHI square test on these important features. So I have used select k best class is applied to extract 12 best features. So initially select k best class is applied for all the features, for all the features, and check for the CHI square test. And one of the further analysis of the feature score, top 12 features are considered and rest of them are dropped. And then the analysis is further done, and CIT indicator is predicted using logistic regression. So F1 score is generally useful when working with imbalanced set. So logistic regression is one of the most popular machine learning algorithm which comes under the supervised learning technique. It is used for predicting the categorical dependent variable. And CIT indicator is predicted by using logistic regression and so as follows. So it is predicted that by logistic regression, it's predicted that it is imbalanced target variable. So considering their F1 source for evaluation performance metrics, it has got 58%. And then K nearest neighbor, it is supervised machine learning algorithm. So the algorithm can be used for solve both classification and regression problem statements. The number of nearest neighbors to a new unknown variable that has to be predicted or classified is denoted by single K. So CIT indicator is predicted by using K nearest neighbors, and so as follows. Here, the training accuracy and test accuracy are not close to each other. Training accuracy is high when compared to the testing accuracy. So which means it has high variance and it is over, and it is overfitted, and its F1 score for further evaluation performance metrics is 82%. And when it comes to the decision tree, this algorithm compares the values of root attribute with the real data set attribute, and based on the comparison follows a branch and jumps to the next goal. And here the F1 score for the evaluation purpose has the got is 87%, and training accuracy and test accuracy are not close to each other. Training accuracy high when compared to the test accuracy means over 15. Depth into the decision tree will cause you high variance at least 15, as I mentioned here. And now next we are predicting using the random forest. It builds decision trees on different samples and takes the majority vote for classification and average in case of regression. Random forest F1 score we got is 88%, which is better than all the previous models as we have observed. And training accuracy and test accuracy are not close to each other. Training accuracy is high when compared to the test accuracy, which is nothing but over 50. And then comes the extreme boost, and CIT indicator is predicted with the help of the extreme boost algorithm also. It provides parallel tree boosting and is the leading machine learning algorithm for classification ranking programs. And here we have got 87% the F1 score, which is less light than random forest model, which we have seen as we can observe it. Here, training accuracy and test accuracy are not close to each other, same as before, and training accuracy is high when compared to the testing accuracy, so it's high variance. And then when it comes to SCM, is nothing but support vector machine, which is a supervised machine learning algorithm that can be used for both classification of regression challenges. It is mostly used in classification problems, and for SVM we have got 72%. The training accuracy and tested are not close to each other, so there is no case for overfitting or underfitting. So, and on an overall, analytic observe for logistic regression, F1 score is 58%, and the highest one, which is better, as we can observe by looking this, all these 5 algorithms are random forest algorithms. It's 88%. So initially, I have done the data cleaning, data modeling, and I have done the features of which is sorry. So I initially I've collected the data and then defined the data. I perceive traits on the data, and then I've summarized numerical columns, and I have chosen the important columns and important the important headers one. I have converted those categorical to numerical values, and I have performed exploratory data analysis. And then I've done feature engineering and feature selection. And then for all the important features which I've considered, I have performed CHS square test, and I have observed the square test observations, and I have chosen top 12 features, and I have omitted the rest of the features. And then in order to see whether it's an imbalanced or balanced set, so I have taken the logistic regression to predict the CIT indicator, which is a target feature for me, as I have mentioned it earlier. So CIC is nothing but a crisis intervention team. So in order to predict the target feature, I have chosen the logistic regression, and followed by the classifiers. I have taken KN and KN sniper algorithm, decision tree, random forest, XGBoost, and SCM, and I have calculated the F1 score for that, which is used for the performance evaluation metric for the purpose of evaluation purposes. Um, and then I have also calculated and seen and visualized the RMC curve values. Um, yes, so I would like to conclude a classification problem is overcome by evaluating various factors such as precision, sensitivity, reconsistency, CT, RMC curve. Among all the algorithms between logistic regression, KNN, random forest model has improved the performance of the model.